Hi everyone, and welcome back to Grade 12 Math with Mr. Simons, where we make math simple and get you exam ready, right? So today we're looking at trigonometry and specifically looking at identities, general solution from the IEB papers of November 2022 and November 2023, right? So without further ado, let's look at the problems. Right, so November 2022, question 8. Solve for x correct to one decimal place in the given interval. So we want 1 minus 2 sine squared x equal minus 1 over 7 for x element of negative 180 to 90 degrees for 5 marks. B, simplify the following to its simplest form. So there's a reduction problem. Minus cos theta times cos cubed 90 plus theta minus tan 180 minus theta cos cubed negative theta for 5 marks. Then we have to prove the following identity by making the left-hand side equal to the right-hand side. And then determine the values of x for which the identity given in A is not valid. So remember, from grade 9 we can't divide by 0. So we're going to look at the bottom when it's equal to 0, then it will not be valid. November 2023, it was question 12 in IEB paper. Prove the following identity. Cos 360 minus 2x minus cos 180 plus x sine 2x minus cos 90 degrees minus x must equal cos x plus 1 sine x for 7 marks. And then again, general solution, cos 2x plus 1 over sine 2x equal 1, 7 marks. So you can pause here and attempt to answer as much as possible and see how many marks you would get. That is just to build the confidence in you, right? Then note where you've made errors as we work through with solving the solutions so that you can work on your errors and master those mistakes so you don't make them in exam. The mistake automatically helps you to remember the problem, so if you see something that's similar, you know exactly what to do, right? So together we will succeed, right? First solution. So solve for x correct to one decimal place in the given interval. So 1 minus 2 sine squared x can be written as a cos double angle, cos 2x equal negative 1 over 7. 1 mark for that. A reference angle, we're going to say shift cos 2x, negative 1 over 7, which will give me negative 81,78. If I say 180 minus 81,78 gives me 98,2 degrees. Or you can go and say reference angle, so shift cos 2x, 1 over 7, ignoring the negative. Get a reference angle of 81,78. Right, so there 98,2 falls in the second quadrant, right? And that's where cos is negative, right? Cos is also negative in the third quadrant. So to third quadrant, 0 minus 90 minus 98,2 would fall in the third quadrant. So therefore 2x equal plus minus 98,2 plus k times 360 for cos 2x. And remember, k is the element of integers. X then, if we divide by 2 in everything, 98,2 divided by 2 would give me 49,1. 360 divided by 2 gives me 180. Right? If we simplify, if I put in 0 there, I have 49,1 or negative 49,1. If I put in minus 1, I can say minus 180 plus that would give me negative 130,9, or I can say if I put in minus 1 minus 180 plus 49,1 would give me minus 130,9. So those are the three that fall in that interval, 90 degrees to 180 degrees. Right, if we go now, different format. In quadrant 2, it is always 180 minus the angle. So 2x equal 180 minus 81,78 plus k360. Or in quadrant 4, quadrant 3, it's always 180 minus theta. So 2x equal, not minus, plus, sorry, 180 plus 81,78 plus k times 360. So that they should read a plus. Right, so the 180 minus that gives me 49,1 plus k 180. 180 plus that would give me 261,78 divided by 2 gives me 130,89 360 divided by 2, 180. There also 360 divided by 2, 180. K element of integers, right? Then if I put in 0 there, that gives me 49,1. If I put in minus 1, minus 180 plus 49,1, it would give me negative 130,9. Right? Negative 180 plus 130,9 would give me negative 49,1. So there have 49,1, negative 49,1, and minus 130,9. So I get the same three angles. So hope you follow, hope you understand. Let's go to the next problem. Simplify the following to its simplest form. So that's what's given to us. So 90 plus theta, I should remember, falls in the second quadrant. The second quadrant cos is negative. So this becomes negative, but 90 changes cos to sine. Negative sine cubed theta. 180 minus theta is in the second quadrant. The second quadrant tan is negative, so therefore it becomes negative tan theta. That stays cos theta. Negative angle falls in the fourth quadrant, so in the fourth quadrant cos is positive. Negative times negative would give me positive, so I have cos theta sine cubed theta. Negative times negative gives me positive, but tan can be written as sine theta over cos theta. That's cos theta over 1 and cos cubed theta. Cos and cos would cancel, leaving me with sine cos cubed theta, cos theta sine cubed theta. So if I take a common factor, sine and cos out. Sine cubed theta divided by sine theta gives me sine squared theta. Cos theta and cos theta cancels. There, sine theta cancels. Cos cubed divided by cos theta gives me cos squared. Then we should remember the square identity. Sine squared plus cos squared equal 1. So sine theta cos theta times 1 simply becomes sine theta cos theta. Right, so up to there we give you 1 mark for finding negative sine cubed theta, 1 mark for negative tan theta there, and another mark for cos cubed theta. So for the 3 reductions, you get 3 marks. Then changing tan to sine over cos, you get another mark, and then the 5th mark for in the simplest form. If we said write in as one single trig ratio, then we would do half angles. So half angle simply means I bring in half. That becomes 2 sine theta cos theta. 2 times half gives me 1. So therefore I haven't changed the equation. But 2 sine theta cos theta can now be written as sine 2 theta as a sine double angle. So therefore as a single trig ratio it would be a half sine 2 theta. But I didn't ask that, so I'm just explaining extra so you understand how we work with a half angle. So this was November 2022, question 8. Hope you understand and follow. Let's go to the next problem. Prove the following identity. So they gave us there on the top. So sine 2x can only become 2 sine x cos x. There at the bottom, cos 2x, they have changed to, because I have cos squared x and sine squared x on the top, cos squared x minus sine squared x. So 1 for each one of the 2. Then 1, I can change to sine squared plus cos squared using the square identity. Same with the bottom, sine squared plus cos squared. So 1 mark for that. Right, so now we have sine squared plus cos squared plus sine squared minus cos squared. So sine squared plus sine squared becomes 2 sine squared x. Cos squared minus cos squared cancel, and I'm left with 2 sine x cos x. The bottom, sine squared minus sine squared cancels. Cos squared x plus cos squared x gives me 2 cos squared x plus 2 sine x cos x. They want tan x, so I know I need to work to having sine x over cos x. So on the top, if I take out the common factor 2 and sine x, sine squared x divided by sine x gives me sine x. There, cos x. So what stay behind? 2 sine x cancel. The bottom, I take out 2 cos x as a common factor. Cos squared divided by cos x gives me cos x. There, 2 sine x. Or sine x stays behind. 2 cos x and 2 cos x cancel. Sin x plus cos x, sin x plus cos x, those two cancel. 2 and 2 cancel. So I'm left with sin x over cos x, which gives me tan x, which equals my right hand side. So there we solve that identity. So 2 marks there for expanding sine 2x and cos 2x, the two double angles. 1 mark for using the square identity, right? Another mark for simplification and 1 mark for factorization. Right, let's look at the last problem. Determine the values of x for which the identity given in A is not valid for 6 marks. So I assume, remember, if you divide a fraction by 0, it becomes undefined. So therefore, automatically, it's not valid. So from what we solved previously, when we did the identity, we got to the point where we had 2 sin x plus cos x, 2 cos x plus sin x. So in short, 2 cos x plus sin x equals 0. If that's equal to 0, the whole fraction becomes undefined. So I can say 2 cos x equals 0, or cos x plus sin x equals 0. There, 0 divided by 2 gives me 0. Shift cos in 0 degrees would give me a reference angle of 90 degrees. On this side here, cos x equal negative sin x equal negative cos x. And if I divide by cos x on both sides, sin divided by cos, tan. Negative cos x divided by cos, negative 1. Shift tan, negative 1 gives me a reference angle of negative 45. Right, so in short, for when cos x equals 0 or tan x is undefined, right, my identity is not valid. So there, for cos, I can say plus minus 90. So cos is positive. We take the 0 as positive in first quadrant or in fourth quadrant. All right. So therefore, plus minus 90 plus k times 360, k element of integers. Oh, by mistake, 2 degree signs. Cancel the 1. And the other side here, x equal negative 45 plus k times 180, k element of integers. Right, so I assume you know those special cases. Right, so 1 mark for taking the denominator and making it equal to 0. 2 marks. 1 for specifying, and then for my general solutions, another 2 marks. So hope you follow, hope you understand. I wish you nothing but the best. God bless. Bye.